see. All right, everything looks good. Alrighty. So, this live stream, it's not really going to be as formative as many of my other live streams, because I don't have like a specific subject that I want to cover. Instead, I'm just kind of streaming what I'm working on, and yeah, figured might as well talk to you guys while I'm doing that. Alright, so I guess I'll go over what I'm working on here. Got a large portion of it already finished. But the big piece is the derive macro, which I haven't gotten to yet, which I'm hoping to finish in this entire session. Alrighty. So basically, I'm creating an algorithm that can diff structs, specifically the identity structs. So create difference structures to see, what's changed inside of the struct. And yeah, so I want to be able to do that, and then I want to be able to post it as JSON or whatever other format. And so that's what this library is for. It's basically taking all these types, and I've created these traits here, and I'm implementing these traits on each of the types so that I can then create a derive macro and derive it on top of the struct that I want to put it on. Hey there, YouTube wonderful. How you doing? I myself am doing all right. All right, so I guess I'm gonna get started here. I haven't really ever done anything like this before, so kind of a new format. All right, so I need to implement all of these traits. Right now I've already got vectors done, strings, options, and I also implemented on all the different numbers, booleans, and characters, as well as the unit type. And so what I want to do is implement all these traits on a hash map type, because hash maps are a big deal inside of the struct that I want to derive this on. And so that's what I'm going to do. So let's start. So basically I'm just defining how I want the key and value to look, and not clone. Hang on. Let me just copy some of this I've got already. Some fairly long ones. So copy this over. And then value be mostly the same, I think. I need to import hash, it looks like. Let's see. All right, and this main trait just has a type called diff, and I want the diff to be, I'm going to create a new struct. I'm just going to call it diff hash map, and it'll have the key and value in it. And so let's create that struct. So I think what I want to do, kind of what I did with the vector type. So with my vector type, I created two structs, one for the inner part of the vector. So we're talking about diffs here. Diffs are the differences between structs. So you can obviously add items to a struct to change it. You can remove items to a struct to change it, or you can update items or change items. And so that's essentially what I want to do with the hash map too. So I'm going to have an inner thing. So call it, let's call it diff inner value inner, or no, inner value. This is for the value itself, but it'll also have the key in it too, and make sure that implements main. It'll be a struct like the other one. Need to derive a bunch of things on it. So I want clone, partial EQ, I want serialize and deserialize. And make sure I spelt all this properly. And yeah, so we'll have a change struct in here with key, which will be k, and then the value, which will be v as main diff. So it'll be this diff type here, and then we'll have a add struct, so key k, and then the value again. We can just copy this over. And then we need a remove, and remove, I think we just need the key, so key k, like that. All right, and then for the diff hash map, let's see, diff hash map with key implementing main and value implementing main, and this will be a tuple struct. So instead of it, hub option of a vector of the inner value. Yeah, and of course need to put k and v in there. Let's see, I think I'm missing a angle bracket. All right, and for this struct, I want to derive some stuff. Let's just derive these things. I think I need to implement a debug for all of these. So let's do that. Okay, so implement a key value, debug, diff hash map. This will be where k implements debug and main, and so does v. And create our f and t function. So, by the way, guys, let me know if the mic is not loud enough. This is a new mic. I'm not really, haven't really used it much. I think I used it for one video and that's it. So if the mic isn't loud enough, you can't hear me, and if I'm like mumbling and stuff, just say something in chat. All right. So I'll use write to the formatter, diff hash map. And then let's create a buffer. And then I can say if let some. I should probably turn off my desktop sound so you guys don't hear Discord. Sorry, somebody is asking me about a different project. Sorry, I just need to message him really quick. And all right, so I'm gonna unwrap the inner part of this diff hash map, and then we want to then print it out properly. So just say buff.entries, and we'll take our value and turn it into an iterator. And then here, you can use standard iter empty spec of the inner value type. Like that. And then we can do buff.finish at the end. Let's see what's going on here. All right, I need to implement debug for the inner value. Right. And you know what? I don't like this format here, so I'm going to implement empty. Import it rather. I can just get rid of this piece. And this actually should be a question mark. All right, so now get debug on the other one. And yeah, it's going to be very similar. Other one. At least this part is. And by the way, the FMT result here is just an alias I created up here. The FMT result type is just called FMT result. Makes things easier because you got multiple result types. Obviously the standard result. And if I wanted to do error handling on my own, I would have my own result type too. So here we've got, of course, our different structs inside of our main struct. We've got change, add, and remove. And we need to, we want to display different things based on which one. So self.change will have the key and value. And for it, we'll go f.debug struct. Struct's name is change. We'll add a field here for the key, and then a field for the value. And then we'll finish. And we can just kind of copy this for the add type and copy it again for the remove type and just remove the value. Like that. That should be good for that. Now, did our errors go away? Oh, whoops. There we go. And that should get rid of those errors. All right, so that's good. Now we can move on. I can move on and start implementing the other traits, the diff, from diff, into diff, and merge traits, which actually have the logic for diffing the data structure. And okay, this is how I want the file to be structured. I'm gonna do diff and for diff, let's see, I think I want basically everything I had here on the key and value, except rather than main, I need to add diff and I need to add on the value diff and into diff. The reason why I'm not adding into diff for the key is because if we have a key and we can either have a key that exists or doesn't exist. You can't really have a key that gets updated. So yeah, thing. All right, so for this we want to implement a diff method. So this takes itself and then another, and then it outputs a diff, which is our type up here in this main trait, diff hash map type. So it takes two hash maps and then creates that other type. All right, so we'll go old. Do I have hash set in here yet? No. Bring in hash set. I'm probably going to have to implement this on hash set too. Much as I don't want to. So hash set. So we'll create two hash sets for the keys, and this is going to use other.keys.collect. Right. Then we need to define what the changed keys are. So we'll take our old and use intersection on the intersection with these two. And then we want to filter where the self k is not equal to other k. We get rid of all the items where the keys are different, or rather, we get rid of all the items where the keys are the same. And then for removed, we'll use old again. We'll use difference. Luckily, this is something that's built into the hash map type difference function, so we can just find out the difference between two hash maps. Then for added, we can do new difference on old. All right, that gives us all of our values, or all of our keys rather. And we can create a vector of inner value. And say for key and edited and change keys. Let's val and new val equal self key and other key. And I may have to type this. This will be their references. So then we'll say diff equals. I want to use the old val. And we can call diff on that. New val. So long as the values in our hash map implement the diff trait, we can call diff on them. And that gives us our diff, and then we can push that diff into the changes vector. So, and in this case, we're pushing in a inner value of change type. The key is going to be our key type, and we're going to need to clone it, and then the value will be our diff. Now we need to iterate through our added keys. We're also going to need to iterate through our removed keys. So for added keys, it's much simpler. You can just say changes push inner value add. The key will be our key clone again, and then the value will be our new with the key in it. Need to clone that into diff. So again, we're relying on a trait being implemented on this type, and let's see. Yeah, so I think this is where I'm going to end up having to implement diff on the hash set. But actually, this is on other, not new. Okay. And then for removed keys, changes.push inner value, remove, use clone again. And then, yeah, we're just going to check to see if our changes is empty. Well, you know what, it doesn't matter. I'll just return changes. If I was going to do error handling, in that case, I would do something where I'm checking to see if it's empty or not. And I need to wrap this in our diff hash map. So all right, and I think I put it in an option, didn't I? Yeah, some changes. And actually, you know what? I can do this if changes is empty. Not empty. Then we have some changes. Otherwise, return none. Like that. All right. Cool. So we've got diff implemented. We need to implement merge. We need to implement into diff and from diff as well. All right. So for merge, again, let me just copy all this. Sorry guys if you can hear my cat snoring. Not really something I can control. Oh look, there are a bunch of people talking in the chat. Sorry guys, let me answer all of you in a moment. So Sam K says, man, you've taught me a lot, thanks. And thank you for watching my videos. YouTube Wonderful is asking what type of macro I'm writing. It's going to end up being a proc macro, so I'm hoping that at the very least when I get to that part, you guys will learn something. JF King W asks if I'm still using Flutter, and of course I am. It's great technology. I'm going to make some more videos on it when I actually have some time. YouTube Wonderful says sound quality is good, but it would be great if I speak a little louder. Okay. I can do that for sure. I can also turn up the gain a little on this microphone. And then Madhav is asking, how can I get a notification on a Flutter app when the data in the API changes? Please help me. You really just if you look at my tutorial where I did the notifications, I think I did a live stream. There's an example where you push a button and it creates a notification. What you would want to do is just take the button, and instead of having the notification be created on button press, you just have the notification be created on the API call. So when the API calls and it comes back with something, and you want to display that something, you just put it into the notification. It's really not that much different than what we were doing before with the button. It's just obviously the cause is slightly different. So yeah, I highly recommend you look at that stream if you want some help. All right, so for the key, instead of implementing diff, we want to implement merge, and then for the value, we're going to do merge and then from diff instead of into diff. And then yeah, we are going to implement this merge function, which takes in the self and the diff and then returns a new self, which would be a new hash map. And yeah, for merge, this is a bit less complicated, I think, than the diff function. Let me make sure my mic is centered. So the new hash map, just use self.clone. So they take the the old hash map, clone it, and then we can apply all the changes through the diff. So for a change in diff into iter, and I may have to implement that on the change its type as a method. So it may just work out of the box. So match change. And yeah, so then we have our different types. Let's see. So inner value change, add and remove. And so, sorry if you guys can hear that telephone ringing. Key and value here. Let me just set up all these. All right. So, and remove only has the key. All right, so for changing, let's see. For changing, I want to get the new hash map. And then I want to call, let's see. So let me get the new hash map. Let's say fake. This will be a fake version of the new hash map. All right, so we get the value out, and then we can use this fake type, or this placeholder type, to then take our v value and call from diff on it. And in there we can pass in the value from here. And yeah, this shouldn't return anything here. What we do want to return though is at the very bottom here, we'll return new. There we go. So into iter, yeah, I think I need to implement that onto the diff hash map. Anyway, I'll do that in a moment. So then for add, we'll go new insert, get the key, and then we'll call from diff on our value. And then, yeah, this should, well, let's see. This returns an option, so I need to wrap this in these and put a semicolon at the end so it doesn't return anything. And then for remove, it's just new dot remove, and we pass in the reference to the key. And that's that. So there we go. And so let me go up to our diff hash map here and implement into iter so that we can iterate over it. So it's kind of annoying to have to add all of these traits. That's all right. Have these ones. And yeah, that should be fine. I just want the key to implement all of that. And then the value. I want it to implement all of these but hash. Like that. All right. I need a comma, of course. All right, so into iter, we're going to need a lifetime here. We're going to return box dyn iterator, where the item is a inner value of kv, and then we'll add our lifetime there. And we can say, oh right, where self is the a. That way we tie the two lifetimes together. And we can say match self.0 to get to our option. And say some diff turns a box new diff into iter, and then for none box new empty. Let's see, there we go. All right, so the empty thing is what I implemented or pulled in here. It's just iter empty. So just creating an empty iterator. All right, and that should have cleared up our little error. Let's see, where is it? Into iter right here. Good. Okay. I guess we could implement a few more functions, or methods rather. I probably want to add a length method. So let's do that. So we're just doing match self.0. And for some d, we'll just get d.lang. And then for none, we'll pass back 0. Alright, and then I could implement an iter function, but I like into iter a little bit more. And I don't see a reason for iter right now. Alright. So now we just need to implement the other two traits, into diff and from diff. And yeah, so let's start with from diff. No. Diff hash map, just hash map. And we're gonna, well, let's go up here and grab all of these. And for this, let's see, yeah, that's right. So the key and the value need to implement from diff like that. All right. And that should be fine, I think. All right. Get rid of hash here. And yeah, hash here too. Anywhere where I put the hash on the value, I need to get rid of it. All right, yeah, that should be all right. Okay. So then this just has the one function, which is just from diff. Takes in a diff and returns a hash map. Just use self new. This is the same as just calling hash map new, but in this case it's implying that it has K and V in it. And we're just going to be returning that map, but we'll go if let sum diff equals diff.0, and we're overriding the diff parameter with this, or rather shadowing it. So then we need our index and the elements in the diff dot into iter. And we'll enumerate on that so we can get the index too. And we'll match on the element. And we're really only concerned with the inner value add type. So here we're just going to go map.insert T and then V from diff. And then for all the others, we'll just say panic. Unable to create diff. Let's see. All right. Yeah, forgot. I need to pass in the value here. All right, and for this, I should put in the index. Diff at index. All right. That's from diff. Now we just need to diff. Or into diff, rather. And let me grab all this again. All right, so Crypto Patrick, hi Tensor. Hear you loud and clear. Well, that's good to know. Yes, so the plan is to do these streams regularly. This is a project I'm working on for Iota right now. I got the okay from them to do some live streams. And yeah, I figured it'd be a good way to kind of show off some of the concepts that I don't really get to talk about too much in my videos, because it's difficult to work with really large projects unless I've already got something. In the case of Iota, with Stronghold, the other project, I had a project that I built from the ground up by myself. But with this other project, I'm working with a team. So you guys will get to see, you know, what it's like to work with a huge Rust project, which is kind of nice. And even if you're not into Rust, I'm hoping that at least you'll be able to see like the actual workflow of a developer on an open source project. All right, so let's replace this with into diff. Oh, by the way, I missed a question, of course. So DSNK24 says, hey, I'm interested in what theme you're using. It's Space Max Dark, and then the font is Code with font ligatures enabled. And there is one thing, so let's... There are multiple Space Max Dark themes on here, like there's a specific one called Space Max Dark. The one you want is the one from Comtier. I don't know if I'm saying that right. And this comes with a bunch of different themes. This other one, I guess it's just not, for whatever reason, it's not perfect. Whereas this one is the actual Space Max Dark theme. And you also get the light theme too if you want to use that. So I do recommend using it. It's a very nice, clean theme. All right. So for, yeah, into diff, we've got everything set up. We just need our one function. and into diff turns a self into a diff. Let's see. I think it's just self non-referenced. Yeah. So again, inner value add the all right, so iterate through our hash map and then take each of the keys, put them into the changes hash map, or each of the values and put them into the changes hash map with the keys. And then, yeah, so this will allow us to just take a existing hash map, do it pretty quickly. In this, it's not an equal, it should be in. Kind of used to, anyway, don't worry about it. All right, so, and then we have our if hash map, and we can do our little if changes is empty thing. We can actually do this inside of the hash map. So some, oh, this should be none rather. And actually, I'm gonna transplant this over to the other place where we did the same thing, because it's a little bit cleaner to do it like this than to have two types like that. There we go. All right, so finally done with the hash map. We can actually move on to the proc macro. So normally, if I wanted more types, I would continue here. I would implement, like, say, I don't know, hash set result, maybe like a slice, arrays, stuff like that. But the example that I'm using, and let's see if I can pull it up for you guys, or the example that or the project that I'm using this for, everything that I'm using is encapsulated in what we've already built here. So we've got vectors, we've got strings, we have options, and we have hash maps. We're not using any complex things like a B tree map or a B tree set or like a hash set or anything like that. So I may expand this later for various reasons. All right, so now we're making the proc macro crate, and we need to derive that as a proc macro crate, or define it as a proc macro crate in the cargo.toml. One thing to know when you're making proc macros, they need to be in their own crate. You can't just add a proc macro to another crate. And then I'm pulling in sin, proc macro 2, quote, and serade derive, or serade derive. And there are various reasons for each of these, and we'll go over them as we work through this. All right. So let me see. Alrighty. I think I also want to import. No, I don't. I don't want to import. I was gonna say I think I also want to import the other crate, the identity diff crate, but I don't have to do that. All right. All right, so what do I need to import? I think I need to import, so let's see, use proc macro 2. I also want proc macro token stream. So proc macro 2 gives us proc macro. This also has token stream. I'm going to call it token stream 2 to differentiate. And that's not how you alias in Rust, forgot. Anyway, there's also, let's see. I'm going to need quote. And the quote macro, quote is kind of like, if any of you guys have ever used Lisp, quoting is like taking code and making it into data, and then you unquote the code when you want to run it. And that's essentially what macros are. You basically are taking code, freezing it, then you add a bunch of stuff to it, and then you reapply it back into the runtime. Or rather, you execute it at runtime rather than at compile time. So parse macro input and then derive input. All right. So then we'll go proc macro derive. We're going to call this proc macro diff, and we'll have some attributes in here. Call them diff. So basically this will look like this. So it'll be like a derive diff, and then in the struct you'll be able to go diff and then add some attributes. It could be like Serday, if you want to use Serday and stuff like that. So we'll create our derive function here, and what we do is we just take a token stream and then we output a token stream. That's essentially what a macro is. It's just a function that takes in a token stream and outputs a token stream. And we use the token stream to basically get all of the stuff that we want. So we'll say parse macro input, which is a macro in itself. We'll say input, which is our token stream. We want to cast this as a derive input. And then we'll have our output, which will be our token stream 2 type. And we'll create a function here called derive internal. And yeah, that's where we will output everything. And then, oh right, I need to reconvert the token stream 2 back into a normal token stream. So token stream, and I can just use the from trait to do this like that, and that should do it. So let's now create this function. This takes in, instead of a token stream, a derive input. It's going to output a token stream 2. All right, and this is going to get a little bit complex. So let's call this in type. This will be an input type. Which is a type we'll create. And actually, let's go ahead and create all that stuff first. So I want to create all the internal logic first. So let's start with some kind of wondering how I want to do this. I think I need to create the input type now. So see. All right, so what I'm going to do is create a submodule here. Call this derive. Sorry about that, guys. All right, and in derive, we'll create our input type, which will be an enum. And we need to make some imports here. So basically, I want to be able to differentiate between an input type that's an enum and an input type that's a struct. And so I'm going to need some of the things from the proc macro to create. This ident2 literal. All right, I'm going to leave all these as they are. So we'll have ident literal span and a token stream. Need all those. Also need to use syn token comma, and we'll use quote, and the quote. I think I spelled that wrong. Format ident, not indent. All right. So syn is like a parsing library. It allows us to parse Rust code. So we can get like commas and different things like that. You can see there are all types of different structs here. You got commas, divs, dollar signs, greater than, equal to, multiply, all that stuff. And so we can add those to our macro setup. So like if I had like a macro that was like this, say derive diff, and then I had like an inner attribute, it was like diff, and then maybe I had some attributes that were like adder1, adder2. I need the comma to be able to determine where the attribute is, and maybe I want the attribute to be like comma something, and I want to do something special with that specifically. So that's what that's about. Anyway, so yeah, speaking of deriving, we need clone and debug on this. And by the way, all the derive traits like this are implemented with this type of macro. All right, so the input type, we have our enum type. If I can type, and then we'll have our struct type. And then I guess we could have a... No, let's just use these two for now. And we need to define the metadata regarding these types. So name, which will be our ident. That's like the identifier for the struct. And then the diff name, again, another ident. The variance. This will be a vector of, and we need to create another type here called enum variance, I think. I'm trying to remember if syn has enum variance in it. No, it doesn't. All right. and it's actually variant. Let's just do this for now. And also let's just do this. All right. Then we need our declarations. So, which will be punctuated. This is a type that's coming out of here. So, this will have our generic param and a comma. Again, another type I want to implement. Then we'll have our params. So we'll have an ident, and a comma. And for now, let's leave that. I'm just going to add a few more, but I think that should be all right for now. Then for struct, we'll have the variant. Then again, the name, diff name, fields, and this should be a field description. Let's see, we're gonna have also declarations and params in here. So I might as well just copy these over. So these are all types that we need to create. Excuse me. All right. Looking at documentation right now, guys, so just give me a sec. While I'm doing that, I might as well field a few questions. Apparently I'm speaking English, but you guys can't understand it. So how's my, I guess my mic isn't going too well, and I'm mumbling a lot. Hang on, let me raise the volume a bit. How's that, guys? Oh, you can't understand what I'm doing with the code. I'm sorry about that. I'm not being very clear with what I'm trying to do. I should actually show you guys all of this, me looking at the documentation and stuff. But kind of being lazy right now. Sorry about that. I'm just looking at the SYN documentation. I'm trying to figure out a few things. Let's see. So generic param actually is in SYN. That's what I thought. I'm wondering why this is not. All right, doesn't implement debug. Okay. Let me re-import all this. Let's see. So this is much more clear what the hell is going on. this is under punctuated. And then the let's see. All right, sorry guys, just one more second. Just trying to figure out where this one thing is. I have a few notes I wrote down about how I want to structure everything. And I'm trying to read through them right now. And I'm not finding what I'm looking for. Alright, you know what, let's just wing it. Alright, so I need the struct variant. This is going to be another enum type. So and let's derive a few things on it. I'm gonna need copy, I'm gonna need partial EQ and EQ. So we'll have a named struct, and we'll have a tuple. And you know what? Let's just remove the struct part. So named, tuple, and then a unit. So those are the three main types of struct variants, and then we need our enum variants. And for this, we'll just derive clone and debug. And so enum variant is actually going to be a struct. We'll have the struct variant here. And then we'll have the name, which will be an ident. And then the fields. Field description. And we need to create that field description type as well. So basically I'm creating these types so that I can describe the different types that I want to derive this macro on top of. So for here we'll have two different structs in here. One for named and one for position. And this will be the different fields in a struct. So if we have a named struct, then we have different named fields. And then if we have a tuple struct, then we have different positional fields. So that's the main difference here. So we'll have name for named, which will be ident. And we'll have the our type, so that we can use the keyword type. And then we'll have a boolean here called ignore. So if we want to ignore this boolean or ignore this field, we'll set that to true. Then for the position, We'll have the position. I guess we could call this index too. This will be a literal type, and then the, again, the type, and then the ignore. And this type should be coming out of sin. So let me import that. Let's see, what's it under? All right, it's under there. All right, this is getting messy. So grab these, get rid of that. Oh, whoops, wrong one. And let's see. Of course, it's screwed up. It's token comma that I want. There we go. It's a little bit better. That seems like I'm getting the wrong type. Let me go back to the documentation again. All right, so type is under token. And then I think generic param should be, it's just under the root. So it should be like that. There we go. We're still getting some errors here, but I'll implement the debugs here in a moment. It's because of this. If I got rid of debug, these should go away. Yeah. All right. So then this again is the debug trait. I still want debug on all these, so I'm going to have to implement it on these different types. It's going to be a lot larger than I anticipated. All right. There's a lot to do. All right. All right, let's start with the input type. So I want a function called parse, which takes in the derive input. It's like all the inputted things in that derive block. So like if I have a block like this, it grabs all of the information that you've added to the struct, basically. And I guess I'm not importing derive input in here. Let's see. All right, it's from sin again. Of course it is. All right, so we want to take our derive input type, so data structure sent, through the proc macro, and we want to convert it into an input type instead. So yeah, it's actually not hard to do, so we can just match on input.data, and we have the different data types. So we have the struct data type, I'm going to have to create a function here called parse struct to deal with structs. And let's see. And I think data is also in sin too. Yep. All right. It's been a while since I've written a proc macro. It can kind of get messy. There we go. All right, I need a comma here, of course. So, all right, check our data struct. If the fields are empty, if the fields are not empty, rather, then we'll parse the struct. Then if we have a struct again, and we don't care about the fields in here, this means that we have a unit struct. So then if we have a enum, this will be data enum again, something from syn. I'll pull it in. I probably should have just glob imported everything, but that's all right. So data enum, all we care about are the variants. And we're going to go parse enum, pass in our input and then the variants. And then, yeah. We could do a union type, but I don't want to have to deal with union types, so just panic able to parse this type. Alright, so we're only going to be able to handle structs and enums for now. Maybe later I'll add union types rather. But not now. Alright, so now let's work on parse struct. This takes in the derived input, the fields, and again another type I need to import. And yeah, and for here we'll return self again. So yeah, remember we're taking the fields here, it's come from this data struct type, and then the input, and so that's the derived input in the fields. We want to convert that into our input type. So we can say new equals, and we'll have another function here called new struct. We could implement the default type, but I think I'm just going to do it this way. And then we can destruct this. And let's see, what fields do we have? So if we have our variant field, and then the fields field, that is our new value, and we want to be able to use them. Get the field identity. And let's see. All right, so we want to get our variants. And we'll create a name struct. That will set it equal to a name struct rather. Then we can call fields.push. And we're pushing in field descriptions of named type. I think my sound is off. I keep getting Discord messages. Apparently I'm very popular today. Alright, sorry guys. BG asked me if I can help him remotely with your SQL exam. Sorry, man. I do know SQL, but not enough to really help anybody with an SQL exam. Mr. Tree points out my typing keeps intensifying, and then AP is asking me what I'm showing. I'm building a proc macro for a difference algorithm. The idea is that I want to be able to find the difference between two Rust structs and then create a struct that contains the fields. And then, of course, convert that into something like JSON or CBOR or message pack or binary or whatever. And then I want to be able to then take that diff and patch it back on top of the struct to get the new struct. So basically it's a way of taking the changes to some value and making them smaller. So instead of having to post multiple of these very large structs every single time something changes in them, I can just post a smaller struct that just encapsulates the change and then reapply it back to that original document to create the latest version. So that's basically what we're doing here. And right now I'm building the proc macro side of things. So you know how you can call derive on an enum or a struct or whatever, and then implement some trait. Basically, that's what I'm doing here. So I'm making it so that we can implement our trait directly on top of a struct type without having to implement all the logic ourselves. Hopefully that makes sense. Is this going to be used for logging, debugging? No, it's going to be used for a main piece of the project. So the main project is this identity project using decentralized identifiers, which are called DIDs. And so the idea is we've got the DIDs, which are kind of like keys in a hash map. And then we've got DID documents, which are like the values in a hash map. The main difference, of course, is that this hash map is completely decentralized. So if you present this DID, then you'll be able to get the DID document anywhere in that network. And the DID document is supposed to prove your identity or prove various elements of ownership over different things, like keys and stuff like that. And so on the Iota tangle, we'll have our DID, or we'll have the DID document, and we want to, of course, shrink everything, so we'll also have the diffs. So we'll have various different DID documents called auth documents, and every time the keys change, we'll update a new one, post it on there. But in the interim, if the user updates their document themselves, then we want to post a diff on there instead. That's what this is going to be used for. All right, anyway, sorry, I kind of went on a rambling little tirade there. All right. So we're pushing in our fields here because we have a name struct, blah, 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 blah. So we want to get our field identifier. That'll be the name. Then the type, which is our type, will be the field ty.clone. And then the ignore will be, I think I'm going to create a function here called ignore field, and I'll pass in the field. Let me just make sure I've got this properly set up. Yeah, that's what I thought. So fields on the scope, of course. All right. I wanted to iterate through everything. So for index field in take the input, or no, I want to take the fields. And I've actually got this backwards. I want to have the sum inside of this. And let's grab this part too. All right, that's better. Though, hang on, this looks all mangled all of a sudden. Right, so this goes here. I don't know why it's mangling it like that. Looks very weird, but whatever. All right, and this should be type R type. And the reason I'm putting that R number sign there is because if I use the keyword type, it'll throw a fit, because that's a what's it called? A keyword in Rust. All right, so in this case we have a tuple. So we'll go fields.push field description tuple struct, or no, it's position, I think. Yeah. And so position will be literal use size. I want use size. Put in our index and our type. Will be field dot type that clone, and then ignore will be ignore field with the field in it again. I don't like all this red, and I'm sure you guys are annoyed by it too. We're going to be returning our new value. Let's make sure we're still in the function here. There we go. All the red went away. Let's see. How did I set up field description? It's name. Let's see. So this is a field da 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 da. Sorry, I know I'm getting quiet, thinking a lot right now. Hang on. Oh, I see why. So this needs to be named something else, so that I can differentiate between the two. Otherwise, I'm going to end up with the wrong types. So I'm looking for sin field, not my field. There we go. That cleans that up. And then this turns into, I think it's ty is type in the field. Yeah, okay. And this one also. Make sure. All right. Well, I'll come back to that. All right. So now let's move on to the parse unit struct function. I'm not nearly going to be able to finish all of this on the stream in the time that I have, but maybe I'll pick it up tomorrow or something. Again, we'll grab this part, create a new struct, and then we'll just say if let self struct, and let me just check real quick what was the fields in that. Variant, I think, is what I'm looking for. Again, we'll destruct a new like that, and then we can just say variant equals struct variant unit, like that, and then we can return new. So this new struct function, of course, we need to make. Might as well get to that now. So this again takes in the derive input. That's a lot of what macros are like, or at least proc macros. It's a lot of sending the same input and just keep passing it through each function over and over and over again. You're essentially just taking the code that you're working with and transforming it into a usable format, and then you need to transform it back into code when you're done. So that's what we're doing. We're basically just taking the code, transforming it into our type so that we can do stuff with it, and then we'll transform it back into code afterwards. So the variant in here will be our, we'll say unit by default, and let's see, what were the fields in this thing? Diff name. Okay. We have variant name, diff name, fields, declaration, all that stuff. Okay. The name will be input.ident. We need to clone that. Diff name will be format ident. It'll just be the name of the struct followed by diff. So this is the generated struct name. So basically, if we have a struct called foo that we want to derive diff on top of, it'll create a diff struct called foo diff. That's the idea. So that's what this identifier is, by the way. The identifier is the name of the struct or the enum, as you can see what the documentation says right there. So we're literally just messing around with the actual characters of our Rust code. Right, so what else do we have? We have declarations and params. That's right. declarations, the input generics params, and we'll clone it. Right, and we need to do a few things with this. Let's map over this. And then we'll collect it back. Right. And then we have, I think, params. And yeah, I want to do this down here. And I want to do the initial, the just clone up here. All right. Let's see, yeah. Okay, so like that. Let's grab this part. This is type params. There we go. I think that's what it is. It's type, it's a function, right? All right. So an iterator over the type params, and then we can put them into our params struct here. All right, that's good. We still need to make our parse enum function. Let's do that. First, let's create a new enum function. So it's kind of like our new struct function, except for the enum. So self enum. We have our name again, which is just the, and you know what, I can copy some of this over. And then we have our variants. Did I write it as variant or variants? Variants, okay. We have the diff name. Diff name is going to be similar to what we did with our struct here. In fact, it's going to be exactly the same. So we just take the identifier of the enum and add diffs to the end of it. And that'll be the name of our created enum. Then we have our declarations, I think. Which again, just grab the generic declarations, or generic params. And then we have our params. Input generics dot type params. And again, we'll map over them. Just copy this. All right. Cool. All right, so now parse enum. Put this right here. So we have our derive input, and then we have our variants, which will be punctuated, where we have the variant and then a comma. And we're going to be outputting self. All right. That's our input in here to make our new enum. All right. And I need to call it like this. And I think I need to import this from syn. There we go. So there we are. All right. All right, so for all these varts in our variants. And again, we're going to run into the same problem. So I'm going to call this enum variants. So we're iterating through all the different enum variants, and then we'll say I'm going to create our new enum variants. And then we need another for loop, I think. To iterate through each of the fields inside of the variants. So we need to iterate through the enum variants, which are the different branches of an enum, and then we need to iterate through the fields in each of those variants, if they have fields, that is. So you can kind of think of it like this. So if I have a fake, well, you know what, I do have enums in here. So for instance, this enum here, if I wanted to diff it, I would have to go through and get each of the variants, so name, tuple, and unit. And then if they had like fields associated with them, maybe they were like structs like this one, I would have to iterate through them like I'm doing with my other struct type. So that we can basically clone them and create a copy of it for the diff. So if let's field ident equals field.ident as ref variant struct variant struct variant name. And variant add field description named. So this is the case if we have a name struct inside of the enum, we want to deal with it this way. So the name will be our fident. Then the type will be field dot, I think it's ty. And then ignore will be, again, we'll have a function here called ignore field. That's in the field like that. And yeah. And we'll have a little else here. And let me just copy all this. We have the one will be tuple, and then positional, or position rather. This will be position, which will be our usize unsuffixed. We'll use our index for that. Then we have our type, and then our ignore again. Afterwards, we want to call enum variants.push, push our variant in there, and then we'll return our new variants, or not enum variants, but the new. There we go. And I think I may have forgotten to do something similar for the struct. No, I didn't. Okay. All right, that looks fine to me. Still don't know why this is all weird, but I'll have to debug it later. Of course, I need to create a new function or a new method for this, but you know what, I'm going to do that later. Actually, I need to go. I've got things I need to do, but I'm glad you guys came and checked out the stream. I'm hoping to do this at least one time a week, maybe 2 times a week if possible. I'm hoping in the future the subject matter won't be as esoteric, where I'm struggling to figure out what I want to do, and it'll be something I can explain a little bit better. Speaking of, a few people seem to understand what I was doing. So Mark, yeah, you'll get to see firsthand how this is used for Iota, obviously. Mehmet says, I'm sorry if I butchered your name. Go syntax is much better, in your opinion? Yes and no. I mean, at least my opinion is yes and no. I like Rust syntax for some things and Go syntax for others. Go is much simpler, obviously, but there are certain things that you can't really express well in Go, and unfortunately that can be a little bit annoying at times. Still, Go is a great language. Don't get me wrong. I love that language too. Just as much as I like Rust. So, Benedict says he refutes it and says that the Rust syntax is beautiful. And yeah, the question mark is wonderful. I don't know if it's beautiful though, but it is a great little feature. And then Pan. I'm not even going to try and pronounce the rest of your name. Sorry. Says that syntax bike shedding is tight, and yeah, it is tight. All right, guys. Well, thanks for hanging out with me for a couple hours here, or an hour, or however long we've been doing this. I think it was an hour. Like I said, hoping to do this at least once or twice a week in the future, and hopefully in the future it'll be a more encapsulated concept, so it'll be something that I can show you the beginning and end of. Yeah, next stream, if I finish this macro by next stream, I'll at least take the time to go through it again for the benefit of you guys, so you can actually see what we ended up doing. Anyway, I hope you guys have a good night.